We are explorers, it's in our nature. We look up at the night sky, we see countless stars, tiny points of light in a vast darkness, and we wonder, what's out there? Are there other worlds like ours? This curiosity is as old as humanity itself. It drives us to look further, to seek answers among the stars. This journey is not just physical, but a journey of the mind, a quest to understand our universe. From ancient myths of sky gods and celestial realms, our quest has evolved. Today we use science, we build incredible machines, telescopes that peer deep into space. We search for exoplanets. These are planets orbiting stars other than our sun. This search is a fundamental part of the human spirit. We long to know our cosmic neighborhood. We want to understand the sheer diversity of worlds that the universe can create. It's a grand adventure unfolding right now. The universe is unimaginably big. There are hundreds of billions of galaxies, perhaps even trillions. Let's talk about a specific alien world. Imagine a planet. From a distance, it looks familiar, a beautiful deep blue sphere. It might remind you of Earth, our own blue marble, but don't be fooled by its color. This planet is HD 189733b, and it is a place of nightmares, a world that looks inviting from afar but is incredibly hostile up close. The stunning blue color of HD 189733b is not from water. There are no friendly oceans here. Instead, its atmosphere is laced with tiny particles of silicate. Think of it as microscopic glass dust. These particles scatter blue light, much like the molecules in Earth's atmosphere scatter blue light, giving our sky its characteristic color. But on HD 189733b, this beauty hides a truly violent nature. The weather on this planet is extreme. Winds blow at incredible speeds, over 5,400 miles per hour. That's more than 7 times the speed of sound. Scientists believe it rains glass. Not water, but molten glass. And because of the winds, this glass rain falls sideways, a deadly high-speed barrage of sharp particles. Now let's journey to another fascinating exoplanet. This one is called Kepler 452b. It was discovered by NASA's Kepler Space Telescope, a dedicated planet hunter. Kepler 452b orbits a star that is quite similar to our own Sun. It's a G-type star. This is important because the type of star influences its planets and their potential for life. Finding planets around Sun-like stars is a key goal for astronomers. This planet has a special address. It orbits within its star's habitable zone. This is sometimes called the Goldilocks zone. Not too hot, not too cold, just right. It's the region where temperatures could allow liquid water to exist on a planet's surface, and as far as we know, liquid water is essential for life. So, planets in the habitable zone are prime candidates in the search for life beyond Earth. Kepler 452b ticks this very important box. Kepler 452b is also interesting because of its age and size. It's estimated to be about 6 billion years old. That's roughly 1.5 billion years older than Earth. This gives life, if it ever arose, more time to evolve. The planet is also larger than Earth, about 60% bigger in diameter. What do we mean when we say a planet is alien? It's not just that it's far away, or that it circles a different star. An alien planet is one that truly challenges our understanding. It's a world that is fundamentally different from Earth, different from Mars, Jupiter, or any planet in our own solar system. These are worlds that stretch our imagination and force us to rethink what a planet can be. Some exoplanets are extreme in temperature. We've talked about hot Jupiters like HD 189733b, roasting close to their stars. Others might be rogue planets flung out of their solar systems, doomed to wander alone in the cold darkness of interstellar space. Some planets orbit 2 stars, called binary stars. Imagine a sunset with 2 suns, like Luke Skywalker's home planet Tatooine. Science fiction sometimes becomes science fact. These double sun systems are real. The atmospheres of these alien worlds can be truly bizarre. We've heard about planets raining glass. Scientists theorize some might rain iron, or even rubies and sapphires on giant hot planets. Some planets might have no atmosphere at all, leaving their surfaces exposed to harsh radiation. Section 5, Shadow Play, the transit method, unveiled. So how do we actually find these distant alien worlds? We can't just point a powerful telescope and take a picture of a small planet millions of light years away next to a star that is billions of times brighter. It's like trying to spot a firefly next to a searchlight from miles away. It's incredibly difficult. So astronomers have developed clever techniques, indirect methods to reveal these hidden worlds. One of the most successful techniques is the transit method. It's quite simple in principle. Imagine you are watching a distant star, a faraway sun. If a planet happens to orbit that star, and if its orbit is aligned just right, it will pass in front of the star from our line of sight. This event is called a transit. It's like a mini eclipse, but caused by a planet, not a moon. We are looking for these tiny eclipses. When the planet transits in front of its star, it blocks a tiny fraction of the star's light. This causes a small temporary dip in the star's observed brightness. We have sensitive instruments that can measure this dimming. Section 6. The wobbling stars detecting planets with gravity. There's another ingenious way to find exoplanets. It's called the radial velocity method, or sometimes the wobble method. This technique doesn't look for dimming starlight. Instead, it looks for the gravitational effect a planet has on its star. Sir Isaac Newton taught us about gravity, that every object with mass pulls on every other object. This applies to stars and planets too. They are locked in a gravitational dance. A star doesn't just sit perfectly still while its planets gracefully orbit around it. The planets also exert a gravitational tug on their star. It's a much smaller tug, of course, because planets are much less massive than stars. But it's enough to make the star wobble, a tiny rhythmic movement, back and forth or in a small circle. The star is essentially dancing with its unseen planetary partners. We observe this subtle cosmic ballet. We can't usually see this stellar wobble directly. The movement is too small to observe visually across vast cosmic distances, but we can detect its effect on the star's light. As the star wobbles slightly towards us, its light waves get compressed. Section 7. Our giant eyes. Telescopes peering into the dark, finding these faint clues from distant worlds. Whether it's a tiny dip in starlight or a subtle stellar wobble, it requires incredibly powerful tools. We need giant telescopes. These are humanity's eyes on the universe. They are engineering marvels, designed to collect as much light as possible and to see the cosmos with stunning clarity, both on the ground and soaring through space. These instruments are key to our cosmic exploration. On Earth, we build massive ground-based observatories, often on high mountaintops, far from city lights and atmospheric haze. Think of the Keck Observatory in Hawaii, with its twin 10-meter mirrors, or the European Southern Observatory's very large telescope in Chile. Its name says it all. These telescopes use sophisticated optics and adaptive systems to counteract the blurring effect of Earth's atmosphere. They gather ancient light that has traveled for billions of years to reach us. Space telescopes offer a crucial advantage. By being above Earth's atmosphere, they get a clearer view. The atmosphere absorbs some types of light, and its turbulence blurs images. The Hubble Space Telescope is a legend. Section 8. New worlds, new questions, the impact of discovery. Every time we discover a new exoplanet, it's a moment of celebration. Each new world is a piece of a giant cosmic puzzle. These discoveries transform astronomy and challenge our old theories. Hot Jupiter shocked us. We had to rethink planet formation. This is the heart of science. The universe is more complex than we imagined. Section 9. Beyond the horizon, humanity's cosmic destiny. The great journey to find alien planets has only just begun. We have identified thousands of these distant worlds, but this is just a tiny sample. Our Milky Way galaxy alone likely harbors hundreds of billions of planets, perhaps even more. Imagine the sheer variety of worlds still waiting to be found. The adventure is far from over. In fact, we are standing at the shore of a vast cosmic ocean, ready to set sail. Future telescopes and missions will be even more powerful. They will be able to detect smaller planets, more Earth-like planets, orbiting more Sun-like stars. They will be able to analyze exoplanet atmospheres with greater precision, searching for biosignatures, the chemical fingerprints of life. Gases like oxygen or methane in specific combinations could hint at living processes. Some future instruments might even be able to directly image larger exoplanets, perhaps even map clouds or surface features. What if we find definitive signs of life on another planet? It doesn't have to be intelligent life. Even finding simple microbes would be revolutionary. It would mean that life is not unique to Earth, that the universe is capable of producing life in many places.